Welcome to the March installment of the Grand Rapids Drupal user group. At this meetup today, we're going to be discussing some simple things you can do with a Drupal site or other sites as well, but specifically Drupal sites to enhance security in a few different ways. And to do this, I'm going to turn things over to Frank.
Hello, I'm Frank. You might wonder who is this random person talking to me. I'm a junior developer here at Rapid Development Group. I'm not a security expert, and that's my first disclaimer of the evening, but I have done some work in this area for some of the RDG clients, and I wanted to share some of that with you guys because what we're going to be tackling is a pretty small sliver of what application security looks like, and that is specifically HTTP security headers. So first question is, what are they? And two is, why should I focus on this? And why are we teaching this today? So an HTTP security header is simply an HTTP header or a subset of them that you can tell your web application to send that will help harden it against different attacks, such as cross-site scripting, man-in-the-middle attacks, clickjacking, and other basic vulnerabilities like that. And part of the reason why we chose this is because it's pretty low-hanging fruit. These are easy to implement on both normal sites as well as Drupal sites. And it's pretty quick to implement, well, most of them with a little bit of an asterisk. We'll get into that later. So first, I'll run over what some of the common headers are, what they do, and then get into the nitty-gritty of how to implement them. And I'll show you an example of our own Rapid Development Group site to show you how this can be implemented. So the first one we're going to talk about is the permissions policy header. This is something that is sent that allows a site to basically control what sorts of features and APIs mainly mobile devices can use and access while using the site, but also hardware on desktops as well. This is stuff like the accelerometer, the camera, or the microphone of the hardware that the application can use. And this is a newer implementation of something some of you might have heard of called the feature policy header. That is now deprecated in legacy. Nowadays, we use the permissions policy header. Basically, all this is a list of directives that lists the API or the piece of hardware that the site can utilize. And then you basically give it a value. The most common value you'll see with pretty much any security header is the self header. And that simply means this website and this website only can use this directive. Then you can also explicitly add external websites. If you're using an API or a third-party library or something that needs access to one of these things, you can explicitly whitelist those things within the directive itself. Second major header is a referrer policy. This is one that allows a site to control how much information your browser is going to include when you're navigating away from a document. So this is just basic information about the site. And this is, once again, just a single string. I will pull up our demo site here just to kind of show you what this looks like in practice. Here we are. So on our tool here that we're using to scan our site, we can see that our referrer policy on this test site is set to origin when cross origin. This is simply one of the many pieces in a listing that you're given here in the referrer policy. And here you're getting a look at one of the easy tools that we can use on a Drupal site to implement this stuff. And that is the security kit module, or SecKit. So as with pretty much all Drupal things, there's a module for that. And this is what enables us to do this really quickly and do it in configuration. So even people who are not coders or security experts can apply this to their sites. So here we're implementing our referrer policy. And this gives you a nice little cheat sheet here on each of the different options that's available, as well as what they do. So strict, origin when cross origin, it'll give you your full referrer information with same origin requests. So that meaning like when I'm navigating to other places on the current site or the current domain, and sending only the origin, aka where the traffic is coming from, with a cross origin request. So if I'm clicking off of our site to go to somewhere like Google or an external link, the information that's sent in the header will only be where it's coming from, not the full information of the site. So this basically just masks information, particularly when you're downgrading from, let's say you're going to some site that does not have TLS or HTTPS protection. This can prevent your site's information from getting sent to a site that does not have good security practices set on it. So that's why that one's decently important as well. Kind of similar to this is strict transport security. This relates to our own website. And that's basically what strengthens our implementation of TLS. And by basically it's forcing the user agent in your browser to enforce the use of HTTPS. It basically says, hey, Chrome, Firefox, Safari, you can only use HTTPS to access this site. Here at RDG, we use a hosting platform called platform.sh that makes this super simple and easy for us to implement within their sort of config as code architecture. So we can simply set some TLS parameters to enforce this header. However, Security Kit also comes with options to implement this up here in the SSL and TLS options. So we can make it send the transport security header, as well as set the max age on it. I'm not entirely sure why the module sets max age at 1,000 seconds. I think the industry standard is 30 days for this header. And basically, that's all you really need to do. Set it and forget it, and things will be running along pretty smoothly. See you guys squinting here. Let me zoom my screen in a little bit so you can read some of this small text a bit better. And then we can also include subdomains of the current domain or origin. Otherwise, if we don't send this option with it, it will only send this header with the base domain of our site. And then the preload function is also for basically, if you are planning on setting this header for the long term or the long haul, this allows this to be prefetched and hopefully load the page a little bit quicker. So this is basically a performance enhancing option. After that, we have our X content type options header. This one basically stops browsers from MIME type sniffing the content type and forces it to stick with the declared MIME type or content type of the site. And there is only a single valid value for this header, and that is no sniff. That's all that you need to send. In Drupal 7, that's something that we add with a custom hook in a module, but in Drupal 8 or 9, the good thing is we don't have to do anything. That is done by default within Drupal 8 and 9 core. So for a vast majority of you out there using D8 and 9, you don't even have to think about this. Drupal 7 sites, this is something that we'll have to use like a hook page build within a custom module to set. But Drupal 7 has a nice little helper function, Drupal add HTTP header, which allows us to manually set headers like this. So everything I'm saying right here, all of these headers can be set manually, and they can be done so as well in other applications other than Drupal. But since we're in Drupal land, we're going to be using the module for these sorts of things. Then we have X-frame options, and this basically tells the browser whether or not you can allow your site to be framed in an iframe. So this can prevent a browser from framing your site to, using like a clickjacking attack to force you to buy something or, click on some malicious link to load some code. And this is done identically in both Drupal 7 and 8 and 9 through the Security Kit module here, where basically we can set, our X-frame options. The basic option here set by default is same origin. Basically means that you can frame your own website, or iframe parts of your own website and other parts of your website, but you're not going to allow anybody else to frame your site. And so this is a good default to stick with. Otherwise, you can whitelist explicit domains down here within their text field setting. And unless you are providing your site to somebody else, or elements from your site to other people for explicit use, like partnering with another organization, it's probably the best to either deny or keep at same origin for this one, just because otherwise there's no real need for anybody to frame your site particularly, except for potentially malicious uses. And those are the simplest ones that you can do in just a couple of clicks within the Security Kit module. Then we have the big daddy of all security headers, which is the content security policy header. This is the most potentially involved one, and the one that comes with the most asterisks. That said, it's also the header that comes with the most security benefits, because it can help prevent cross-site scripting attacks with injected code. So even if a malicious actor has somehow gained access to your site or your web server and is injecting some sort of malicious script or something like that within the code of your site, this header can allow us to block that. And that's why it's so powerful. However, that also comes with a lot of caveats, because it is a whitelist based policy, much like any other security header that we've talked about. And so by default, it blacklists everything, including stuff that is vital to building your own website's pages. So it'll block all JavaScript, it'll block all iframes, it'll block all CSS by default. And so we have to slowly piece together what is necessary for our website. And since we have so many different, in modern web apps of third-party libraries and dependencies that we need to build our site, jQuery, as one notable example in Drupal, we need that for our site to function. And if we just send this header without configuring it properly, it's going to break our site and we're going to have to roll back. So luckily, the Security Kit module comes with this nice little report only option. I can't stress this enough. Use the report only setting. If you are setting this header, go report only at first, and then this is going to be a probably long and arduous process of figuring out how to whitelist everything your site needs. There are some methods that we can use to ease this process that I'll go through in a minute here. But due to the nature of generally large web apps, this is, at least in our testing and implementation of this, it's almost impossible to implement on a large Drupal site, simply by the fact that this is done on a page-by-page basis, including admin pages. So this will also block requests to admin pages, so it can break your admin experience as well. So while this is very robust, I would only really recommend using content security policy on something like a one-page site or a small informational site that doesn't have a ton of pages, simply because that'll cut down the amount of manual work that you'll have to do to go through and whitelist all of these things. So what does that look like in practice? Well, we'll save our configuration here and check out the site. So all of the reports for content security policy can be found within your web browser's inspector in the console. And it will show up. All violations of your set content security policy will show up as errors within the JS console. Let me zoom in on this so everybody can see it a little bit better. Well, maybe not. Anywho, you'll see this little prefix here. It says report only. That tells us we're in reporting mode. And this is going to tell us every single violation of our set security policy. If we set it to go live right, in 1 second here, this is the stuff that's all going to get blocked. So we have at least 730 assets that would be blacklisted by the content security policy header. Really robust for keeping bad actors out, but this would also white screen the site. So let's break down what each of these reports means and how you can use them practically on a Drupal site. So this will give you some key things. It'll tell you the policy that's being violated, so the directive, and then what is set currently, and then what you would need to set in order to whitelist that thing. So here on our top one, it refused to apply a inline style because it violates the default source self directive. So just as a blanket policy within our settings here, I have set simply the default source, which is the fallback of if there is not a directive set explicitly, it will always fall back to the default. And self is usually safe for this just because it allows stuff that your domain is that is attached to your domain to go. So stuff like CSS and JS that is provided by the site itself is allowed. Then we have other major directives like scripts, what sort of scripts can be run on the site, what sort of styles, what sort of images, media, what sort of iframes, if you're embedding YouTube videos, you can whitelist stuff like that. Fonts, if you're using external web fonts, you can whitelist them here. Stuff like that, connect sources. So for HTTP requests, WebSocket requests, other stuff like that. So if we go back here, we need to, according to the security kit module, use the unsafe inline keyword within our default source directive or in our style directive. The other things you'll see here are hashes or nonces that enable these things. So a hash is basically just a hashed version of the script or style that is going to be applied. It sits as a stand-in. So if it's something that is necessary on every page load, so something like an injected inline script or something like that, we can take this hash here, copy it, and paste it into our policy directive, and it will whitelist that specific resource. Or in something like a D7 site, we haven't found out how to implement this on D8 sites yet, use the nonce directive, which is basically a randomized number hash that is applied to stuff like scripts and styles. For example, there is something we can implement here with nonces on Drupal 7, which basically will generate for every single HTML tag with the script or style. It'll add this global generated nonce, and then we can take that and apply it to our SecKit options and apply this globally, basically, and takes out a lot of the manual labor of copying and pasting hashes or whitelisting certain domains. This approach is something we've used on a couple of client websites, and it works really, really well for D7. And I know that there are a couple of issue queues on D8 for implementing this as a part of the SecKit module, but those are still in progress right now. So we'll set those things. And you'll see here a lot of things like loading style sheets, and you'll get a URL. So JS Deliver or fonts.google APIs. These are our third-party resources that we're going to need to generate some stuff on the site. And it's violating our policy. So how do we whitelist this stuff? Well, we're going to take our URL here, go back into security kit. This one is a style sheet. So we're going to go into the style source, and we're going to take this base domain here and then break down how to make this as global as possible. Luckily for us, the wildcards, the star is allowed here. And so if we prepend our googleapis.com, we replace this subdomain with A star, that'll tell us any subdomain of googleapis.com we're going to whitelist for styles. Then what we can also do is add a colon and a star to allow content from that site via any port. So either via HTTP or HTTPS. So this is basically the catch-all for a directive. And then we can do the exact same thing here for our JS deliver as well. That's also a style sheet. So we'll put that in our style source. And save our configuration, and then reload our page. And what we should see is those two violations at the top are going to disappear. We don't see them anymore. So those assets are whitelisted now. So the first thing that I normally do when I am implementing a CSP header is to get all the third-party stuff out of the way first, because that's the sort of stuff that's likely to break first off. And then you would do stuff like whitelisting, if there are embedded videos on the page, you will add that sort of stuff to your frame source. If you want to frame Vimeo videos, YouTube videos, et cetera, et cetera. You'll also see these huge nested violations. This stuff being, jQuery assets from Drupal core that are going to be blocked. So we would have to add that as well. The big problem, and this is the huge asterisk that comes with the CSP header alongside of simply a lot of manual labor doing this page by page, is that the way that Drupal works, there are some assets that are inlined or loaded with a page explicitly every single page load and every single page request. So oftentimes this is what we run into, is we will have a pretty robust CSP set for a site, and you will still see violations even if you've whitelisted everything. And that's because we've added a hash for this thing. The report says, well, just add this hash to allow this script. Okay, we add that, or this style, and then you reload the page and the hash has changed because it's a new implementation or a new version of that script or that style. And there's no way around this as far as I have found on a Drupal site. So the workaround here, which kind of kills the implementation a little bit, is using the unsafe inline and unsafe eval directives. Now, these allow inlined content, basically, to be put there. And that's obviously unsafe for obvious reasons. If somebody's injected a script inline on your site, it'll be able to execute it. But if you're also getting, core, injected styles blocked, that's also going to break your website too.
I imagine there's some theoretical way of if you understand how that hash gets generated, probably some way to calculate that at the time aggregation happens, but it would not be for the faint of heart.
Yeah, and that's something even deep in the issue queues and Stack Overflow about this topic that I have not seen anybody talking about in terms of implementing, even though it's a known problem. So this is something that is incredibly useful, and we only just kind of touched on the bare surface of content security policy. It's something I'd only really ever recommend implementing on something like one-page sites or pretty simple, smaller informational sites. On a big site, you're just going to be spending hours and hours and hours and hours bashing your head on every single page looking for these directives. And actually, I've run into a need to actually patch the module before to change these inline text fields into text areas with basically, infinite size to allow the sheer amount of hashes that were necessary to whitelist. And this was on a site that has, I think, like 5 or 6 pages. So this isn't for the faint of heart.
So the earlier things, though, that you were mentioning before this directive were pretty straightforward, right?
Absolutely. Yeah. Everything that we talked about before the content security policy header, so all the other policies we talked about, permissions policy, refer policy, strict transport security, our content type and framing options, all of those come out of the box either with Drupal or in the security kit module and can be implemented in just a few clicks after installing the module. So those are the low-hanging fruit that I would recommend pretty much everybody who has a Drupal site to use, because this is really easy to implement and it closes up a couple of loopholes and vulnerabilities that would exist otherwise. So that's the basis or the basics of what I would recommend. And for people who are not using Drupal sites, this can all be done, or well, I should say, if you want, manual control over this, and you say, okay, we don't want to use the SecKit module. I want to do this programmatically in my own application for whatever reason. In D7, we have the Drupal add HTTP header function that we can utilize. And you simply provide a header name and then a value for that. And then Drupal 8 or 9, Symfony provides the heavy lifting for us. We can use our response class here and then set a header in a very similar way to Drupal 7. So if you want more granular control than the module can give you, you can use this.
That's great. Thank you.
So yeah, that's the basic overview of HTTP security headers. And I guess I'm going to open this up to questions now and other people to talk about their own security implementations or recent projects that they've been working on.
Yeah, mostly I've when I've encountered this kind of thing, it's been the opposite direction of needing to specifically allow cross-site communication when, say, one site is consuming a data feed from another, and you have to, and that's a similar problem of putting out the right headers to allow that. So this is it's a matter of which side of the defaults you're trying to get to.
Yeah.
Great. Thank you.
Yeah. One more quick thing. There's another. I did forget to touch on this in the permissions policy header. That is actually a separate module, the permissions policy module on D8 and 9. And that simply gives you, once again, an easily configurable, GUI to basically pick and choose on a granular basis what features you want to enable on your site. So if we want to allow our application to utilize the camera hardware of a computer or something, this is what we can set it with. And then we can also set it to all sources, or whitelist specific sources as well. If there's a third-party library that we want to enable use of a camera, so let's say we're implementing a chat app or something, a FaceTime sort of thing, and we need to let our application utilize the camera, we can set that here. And then within D7, that has to be explicitly set from that Drupal add HTTP header function within a custom module. So this is a lot nicer and easier to do in D8.
Great.
I have a question. I know nothing about this, so can you explain like how you know if you need to be worried about this kind of stuff, or is in general, will you be pretty okay with the defaults with Drupal, or like how do you know when you need to enable that module and do some special stuff?
I think this got on your radar, Frank, wasn't it through a credit card like regulatory review or something like that?
Yeah, it was a while ago at this point, but I think it was kind of a twofold thing. It was like two separate clients talked about something like this in very close proximity to one another. And so we just decided, okay, we're going to do some research and figure out how to do this. I think one of them was explicitly security related, like you said, with transactions. And then the second was an SEO review, actually. They were talking about hardening their site, from a security standpoint to hopefully improve their SEO, which is a nice little, perhaps positive externality of this. But I think, to your question, Haley, this is something I think it's easy enough to do that in pretty much any Drupal implementation, you could do this and probably should do this, just because it probably won't have any negative effect, especially if you're not utilizing the CSP header and all the complexity that goes with it. And you only get real benefits out of it because you're limiting the number of vectors of attack that a potential malicious actor could take. But out of the box, Drupal does a pretty good job with security, just because they have the security team keeping tabs on things like contributed modules and core and such. So this is just like a little bit of a low-hanging fruit to slap an extra layer of protection on top of your site in a pretty quick way.
Okay. Thanks.
Yeah.
As always, if you have ideas for future topics, please leave them in the YouTube or Meetup comments.
Mm-hmm.